Good morning, everybody. This is Ed Brokish at Kansas State University, sitting in for John Hay on his Bioenergy Friday web series. And today I am doing double duty as being a monitor as well as presenting today. And today's topic is ethanol and legacy engines. I'm a specialist, extension specialist here at Kansas State, working in the machinery and energy area. I've got a lot to cover today, and so I'm going to jump right into it and start the presentation here. So, why this topic? Well, it all comes back to the renewable fuel standard and the mandates for the amount of ethanol that's to be consumed in our fuels. The RFS shoots for 36 billion gallons annually by 2022. We're hopeful we're going to consume 12.5 billion gallons this year. We'll consume it in either E10, E85, E-diesel, or the new kid on the block, E15. E-diesel is not really very common here in Kansas, or at least I haven't seen it at many stations, but I've run into it a couple times over in Illinois. To meet this, these amounts of fuel, the refining capacity has been built over the years, and that has driven down the cost in spite of the fact that we've had the drought and there's been a shortage of grain out there. The costs are coming down on ethanol, and so more and more is becoming available. What got me started thinking about this is with the advent of the E15 being allowed, and I started thinking about what its impact would be on small non-road engines. Well, as I was preparing a paper on that, I suddenly realized that legacy engines also have some of the similar impacts that we see in the non-road engines. Also, as I was preparing that and thinking about those legacy engines, I started thinking about these old tractors, and that is how we got to this topic in this presentation. So, legacy engines. Well, for cars and trucks, anything that's older than a year is really a legacy engine, but I have broken it down into a number of different breaks for legacy engines. There's the pre-1971, which is essentially 1971 is the time when we started thinking about lead, tetraethyl lead, and taking that out of fuels. 1975 began the end of lead. The mid-80s, we had the energy shocks in the 70s, and so in the mid-80s, we begin to see ethanol coming into, or I should say the late 70s, we had ethanol come into the fold, and in the mid-80s, ethanol tolerance was built into a lot of the vehicles. And then 1996, we started to see a wider use of ethanol, primarily in E10, but in other blends. And then we've seen as late as 2001 with the EPA now in 2010 allowing the use of 2001 and later model year vehicles being approved for E10 usage. On the tractor side of things, the legacy engines is really pre-1970, and as it relates to our conversation today, it is definitely pre-1970 because that's about the time we saw the conversion from gasoline tractors to diesel tractors. I mean, there was diesel tractors before 1970, but about the time of 1970 is when we started to see fewer and fewer gas tractors being offered, and so those are the ones that we're thinking about today. These legacy tractors are simple and durable. They have survived for years and years. They are treasured machines. I don't know how many times I have had a conversation with somebody about old tractors, and they're saying, yeah, we've got this tractor here. It was Granddad's first tractor. It was Dad's first tractor, and he really loved that machine, and so we keep it around, and it means an awful lot to us. The other thing about them is they're kind of a convenient size. They're just, some of these old tractors, the one that you see in these pictures here is a 6 horsepower Cub Scout, It is essentially a garden tractor, and it's still in use as a garden tractor. Our hero John Hay is over there on the right plowing his garden, and his granddad is the original purchaser of the tractor, is there on the left and plowing his garden back in the late 70s, early, or maybe even as early as the 60s. The other thing about these tractors is they can be bought relatively cheap, and so a lot of the sundowner farmers who have small acreages and are out there wanting to do some work on the weekends, they can buy these economically and have a lot of power for a little bit of money. So those are the reasons why these tractors have stayed around, and we'll progress on here and talk about how we're going to proceed today. First off, we're going to talk a little bit about definitions. Then we'll talk about gasoline. And when I say modern gasoline, what you would get at the pump without ethanol. We'll spend a little time talking about ethanol, talk a little bit about fuel systems and combustion. Those two topics are actually switched. We'll talk about combustion first, and then we'll look at a little bit ahead and then have some time for some questions afterwards. Definitions. Octane. Probably one of those things that people do not understand when they go to the fill up, but when it says octane rating, all that means is the resistance of that fuel to knock or ping. It has nothing to do with fuel energy content. It is strictly octane is an anti-knock measure. So if you have 87 octane, 89 octane, or 91 octane, the only thing about the difference between those fuels is the resistance to knock of that fuel. Energy content, on the other hand, is the amount of BTUs, the amount of work that a gallon of gas or gallon of ethanol can do. There is a difference between gas and ethanol, and we'll talk a little bit about that later on. But that is different than octane. And octane and energy content are not really related. Air-fuel ratio, that has to do with the ratio of combustion air in the combustion chamber to the fuel. And when we talk about it, you have ideal combustion ratios, which is you have enough air to completely combust all the fuel that's in the combustion chamber. And we'll talk about some variations off of that. Lastly, we'll talk a little bit about vapor pressure, depending on how the program proceeds. So, the blends that are out there. I haven't listed E0, which would be pure gas. E10, that's a blend of 90% gas and 10% ethanol, and generally considered usable in all engines, though there's some of the older engines aren't labeled for it. E15 is a blend of 85% gasoline and 15% ethanol. Again, that's for 2001 and newer vehicles. That's the new kid on the block. The bottom is actually should be saying E85, which is a blend of 15% gasoline and 85% ethanol, and that's only allowable in flex fuel vehicles. They're the only ones that have the oxygen sensors and computer controls that allow you to be able to allow those engines to be able to adjust to different ratios. So you can have E0 to all the way up to E85 in the tank, and the engine in a flex fuel vehicle will adjust to have the right mixtures to get the right combustion and operate properly. Now, please note that when it says E10, that means that there will not be any more than 10% ethanol in the fuel. It can have less, but it will have no more than 10% on an E10. Likewise with E15, E85. Let's talk now about gasoline. It's changed over the years. It's changed for a number of reasons. Environmental regulations being one of the big drivers. We talked a little bit about lead. We recognized in the in the 60s that lead was doing damage to the environment, and so the decision was to take that out. Then we had MTBE used in the major metropolitan areas to help reduce smog and other conditions in the atmosphere in those areas, and those have changed the fuels. The other thing that's happened is the engine design has changed. We've used to have carburation in most vehicles. Now we've gone to fuel injection. Making that change has allowed us to do some different things with the fuels, and vice versa. The engine companies have asked the refiners to do some things differently to make the engines run better, and so the fuels changed to accommodate this new technology in engine design. Then we come to the refiners. They have not stayed stagnant in what they do. They have figured out how to get more fuel, gasoline out of a gallon of oil. They have worked on their quality to be more consistent. And so as a result, you have had quite a change in fuels over the years, even though it still looks the same when you pour it into your vehicle. So legacy engines, an engine made in the 1950s was designed for the fuels of the 1950s. The fuels of the 1950s are not really the same. They're very close, but not really the same as the fuels that you find today at the local filling station. The other thing about gasoline is they're pretty complex. Ethanol, pure ethanol, is made up of one molecule, one type of molecule, and I'll show that to you here shortly. Gasoline, on the other hand, has quite a range of molecules in it, ranging from a C6 hydrocarbon chain to a C12 hydrocarbon chain, as shown here. And then it has many additives also in the fuel for some other purposes besides just combustion. So, again, major gasoline additives over the years has been tetraethyl lead, which was started to be phased out in 1975, and wasn't truly removed completely from gasoline until 1995. And then we had MTBE come on the scene back in the mid-'80s to help reduce air pollution. And then that was discovered that was a major groundwater contaminant, and so that was phased out. But to replace MTBE, we realized that we could use ethanol and oxygenate to replace it. And so over the course of the early 90s to 1995, ethanol began to replace the MTBE, and then in 1996, ethanol was replaced MTBE completely. And about that time, and people may argue with me on that, and that would be fair, that but I would argue that 1996 was about the time we started to see ethanol become widely blended in gasoline around that E10 amount. Yes, there was the ethanol E10 available before that point in time, but I think we started to see the bulk of it become blended after that time. Gasoline has a whole bunch of other additives in it. It has some detergents that will attack polymers and metals. It's there primarily to keep your injector tips in an engine clean. Without that, you would have some buildup on the end of those tips that would cause drivability problems and performance problems. And so the refiners add a detergent to keep the tips clean. And the gasoline also has some anti-icers, fluidizing oils, and then a number of corrosion inhibitors, antioxidants, and metal deactivators to help prevent damage to fuel systems from the detergents that they've added. And these fuel systems we're talking about are both the local filling station, the engines, and your pipelines that carry the gasoline around the country have the people that run those have asked for these things to be added into the fuels and to help protect the engines. So if we were to think about this, we have a lot of concern about what ethanol might do to some engines. There's already some stuff in gasoline that we need to be thinking about too. And we'll come back to that thought a little bit later on. So, what is ethanol? Well, it's a material that is made from organic compounds. It goes by the name of ethyl alcohol. Ethanol, shorthand for it is ETOH. We call it fuel alcohol. We've used gasohol, which is actually an ethanol gasoline mixture, but you will find ethanol used in a variety of ways. So it's kind of generally a generic terminology for a fuel containing ethanol, but it may have a gas component to it also. Pure ethanol is then pure ethanol. Chemical composition of ethanol is listed there below. It's a C2H6 with an oxygen component to it. The other way it's written is C2H5OH. It's always available as a fuel in a denatured form, meaning that you can't drink it. It is not methanol. Methanol is a completely different substance that is very, very aggressive and really not very pleasant to be around. Ethanol is made from corn, grain sorghum, sugar cane. Those are the more traditional ways of producing it, but we are working on ways to make it from cellulosic biomass items such as switchgrass, corn stover, and wheat straw. It's been around for a very long time as a fuel. Henry Ford advocated for it back in the teens and 20s. It was used during World War II by Allies in Germany to help fuel their war efforts. And then in the intervening years between World War II and the mid-70s, it really died out as a fuel. But then in the late 70s, again because of the energy shocks, then we started to see it appear as a fuel. 15% blend was the first thing that we saw, and when it showed up in the late 70s, there's real problems with the quality and blending of the fuel into gasoline. And I will direct your attention to the little green pickup in the right-hand corner there. That was a vehicle I used to go to college, and I had a bad experience with some E15 at that time, or some gasohol as it was called, and I remember that for quite a long time. And at the time I blamed it all on the ethanol alone, but I believe what it was likely happened to me there was the quality and blending problem, where they had overblended the ethanol, and it was less a case of the machine having problems with it, was as opposed to having too much ethanol in the system. And it was a memory that stuck with me until the mid-90s, and I have a much different opinion on ethanol as a result of that experience in my research since then. The other aspect to that is the vehicles of the mid-70s, they hadn't thought about ethanol when they were designing them. Once we get into the mid-80s, they started realizing that ethanol was going to be in the fuel system, and so they started building engines to tolerate ethanol. And then, of course, in 1995, ethanol became widely accepted, added to fuels as the MTBE replacement, and we started seeing the 10% blend for general use in fuels. Today, you can find ethanol in most gasoline. 70% of all gasoline at a filling station, or sold, I should say, 70% of all gasoline sold in the United States likely contains ethanol. There is no labeling requirement in some states so that you can pull up to a filling station here in Kansas and Nebraska, most likely also, and fill up. There'd be no label on the pump saying otherwise, but it could have up to 10% ethanol in it. If you pull up to a station that says, hey, we have no ethanol in our fuel, there's still likely some ethanol in there as an MTBE replacement. So it's a widely used additive. It's approved by EPA for use in most vehicles at a 10% max blend level. There's only approved for limited use above 10%. Again, for 2001 newer model year vehicles, E15 is allowed, and then the flex fuel vehicles can go between the E15 and E85. Ethanol properties. Octane. Pure ethanol is 100 octane rating. It has this higher octane rating, works better in higher compression engines. Most of your gas engines are in that 7 to 8 compression ratio. Ethanol can operate at a little higher octane or at a higher compression ratio. So if you have a vehicle that is burning some ethanol and the compression ratio isn't very good, meaning it's an old, the compression isn't good in the engine, you may want to rework the engine and get some compression back, and you'll get a little better performance for the ethanol containing fuels. Energy content, the engine is related. Gasoline has about 117,000 BTUs of energy in it. Ethanol is about 66% of that. At the E10 blend, when you're operating a vehicle, you should not see any difference in performance or fuel economy. I will use the example of a vehicle I drive to work daily that I fill up at the local filling station, which I honestly don't know whether the fuel I use has any ethanol in it or not, but on the weekends I will drive that same vehicle on a 100-mile trip. I stop at a filling station that advertises E10 and fill up with that fuel there, and my vehicle runs at a much higher miles per gallon, about 2 miles per gallon greater on the E10. The difference is strictly the fact that the way I drive the vehicle on weekends is much, much different than the way I drive it during the week back and forth to work. And the result is the way I drive has a bigger impact on my fuel economy than the energy content of the fuel. So E10 does not really affect your fuel economy. Ethanol is hygroscopic in nature. That means that it attracts water. Gasoline, by contrast, is hydrophobic. I'll come back to that point. Ethanol's volatility is a little greater than gasoline, and so it tends to cool things within the engine, and I'll explain how that happens shortly. The other thing about ethanol is it is a mild solvent, so it will dissolve deposits, varnishes, and stuff inside engines, and that is a good thing. I want to talk a little bit about combustion in order to explain another point in how you should operate an engine with ethanol in it. Basic combustion, you have fuel plus air. When you combust the two together, you get water and CO2 and some energy. How that works in your engine is you take ethanol, the C2H5OH, combine it with air, which will have in the perfect combustion where you have the right amount of oxygen to completely combust the ethanol. you have 3 oxygens and 11.28 nitrogens. In this case, the 11.28 nitrogens is approximating the rest of the stuff that is in air. There's more than just nitrogen in air. Okay, you combust those items together and you get your 11.28 nitrogens back. You get 2 carbon dioxides plus 3 water molecules and some energy out. Your air-fuel ratio is based off the weight, the molecular weight. You add up the molecular weight of these 2 components and divide it by the molecular weight of your fuel, and that is how you can calculate your air-fuel ratio. So, for ethanol, at the perfect chemically correct reaction between air and fuel, you have a ratio of 9.0. For gasoline, for the chemically correct air-fuel ratio to get the proper combustion, you have a ratio of 14.1. I've seen it as high as 14.7. Again, remember the complexity of gasoline, you can have a little greater range there. Ethanol, on the other hand, has this one molecule that you're dealing with, so it's a little finer range that you're thinking about here. So, variations off of that air-fuel ratio, then, if you have a higher ratio, meaning, say, for gasoline, your air-to-fuel ratio is 17, that would be then considered a lean mixture. If you have a smaller ratio, that is a rich mixture, and what that means is you have more fuel to air. So, example would be is our air-fuel ratio where you've got the perfect chemical mix of 14.11. If you drop it to 12.0, that would be a rich mixture. Now, the air-fuel ratio in an engine is seldom chemically correct. One, that's because there's a lot going on, and so it's a little hard to control that. But the other thing is manufacturers often set their engines to run rich. They get more power out of the engine by doing so, and they also have the engines run cooler as a result. As you're running a little greater fuel charge into the combustion chamber, what happens is it absorbs more heat out of the chamber to cool to volatilize the fuel, and as a result, that pulling that heat to volatilize the fuel, that cools the engine chamber or the combustion chamber some, and so your engine will run a little cooler with the richer mixture. So, what happens when you add ethanol to a gasoline mix? Well, that tends to lean the mixture some. Because ethanol contains this OH, or more precisely the oxygen, that tends to adds the more oxygen into the combustion chamber, so that tends to increase, even though you may have not changed your air-fuel ratio, it changes the air-fuel ratio to be. What I mean by that is you haven't adjusted your engine's still flowing the same amount of fuel that it was before, but now because it has a little ethanol in there, it is essentially now a leaner mixture. This is called enleanment, and some of the symptoms that can come from this is a little bit of power loss and engine heating. Now, power loss in older engines and older tractors is probably a good thing. Let's go back to tetraethyl lead in your engines. That was there to prevent exhaust valve recession. When we took the lead out of gasoline, if you run your engine at full power or high RPMs, in the case of road vehicles, you start to do damage to your engine. The addition of a little ethanol into with modern fuels into a cylinder will reduce some of your power, but to prevent exhaust valve seat recession, you do want to run your engine at a little less power. You don't want to run full power so that you don't do as much harm to your engine. So having a little ethanol in there and reducing some of your power in an older engine is a good deal to help keep that engine living longer. The other thing is the heating, and that's a little bit bigger issue and something of some concern, and I'll explain shortly when we talk about carburetors what you can do to help that. Now let's talk about the fuel system as a whole in an old legacy tractor. We're going to talk about carburetors. For your older cars, road vehicles, then an accelerator pump, you'll find that in those, but not in tractors. Filters, fuel pump, again, not likely in an old tractor, but an older car, you'll see that there. Your fuel lines, fuel tank, and just a brief bit about the intake manifold. Carburetors. First thing that we think about, and at least I think about with regard to ethanol and carburetors, is material compatibility. You want to look at seals, the jets in the engine, in the carburetor, the float, and then the needle valve points also all have some things that you need to pay attention to. The seals, of course, certain materials, the ethanol will deteriorate, some natural rubbers, some polyurethanes, certain corks, some leathers to an extent, some PVCs, polyesters of some sort are all susceptible to ethanol. Your jets, certain materials can be corroded. Usually what will happen here is you'll have a material there that will corrode a little bit. You'll get a little bit of white rust, and then what mostly will happen is that rust will wash away and plug something. Floats, likewise, can have a similar problem. Over here on your needle valves, the points of them can be a polymer in some instances, and that can be deteriorated, and then that'll change your fuel flow rates a little bit. And so you may need to go back in and if you need to rebuild the carburetor and put in compatible materials. Your ports, there's a lot of little openings and things inside your carburetors, and when you're running ethanol, particularly if you have an old engine that hasn't run for a long time and you take and you dump some ethanol into the gas tank, it may clean the engine and fuel system, or clean the fuel tank and everything out of all the deposits. Well, those deposits may come off as chunks and wind up in all the little holes and ports within the fuel system. So you need to watch for plugging when you first start using an ethanol or first start using a vehicle that hasn't had fuel in it for some time. Carburetors. One of the big things you want to think about if you start using an old tractor for the first time for a while is paying attention to the how your tractor operates. And if you know you've got ethanol in the engine, you probably need to start thinking about richening the mixture. The main jets need to adjust the needle valve so you get a little more flow. If you can't get enough fuel flow, you can't get the mixture rich enough, go ahead and replace them with something a little larger so you can get the proper fuel flow. You also want to pay attention to the low idle and adjust the valve there so you get better flow there. Why do you want to do this? Well, primarily for the engine heating problems. You need to make the mix richer. What happens is that kind of like an acetylene torch, if you take and lean out an acetylene torch, you can get a really, really hot flame. If you richen an acetylene torch flame, you get kind of a white flame there that is really not as hot as when you lean it out and you get a nice crisp blue flame. That's kind of what's happening when you lean out the fuel mix going into your combustion chamber. You get this hotter flame, And so by making your flow of fuel into the chamber a little richer, you reduce the combustion temperature within your cylinder, as well as we talked already about the volatilization and how much more heat that takes to reduce the heat in your engine as it operates. The other point, and we'll talk a little bit more about it shortly, is that the carburetors tend to be vented. If you're going to store a carburetor or an engine for a while, you ought to shut the fuel flow off to the carburetor, either drain it or just let it evaporate out. It'll save you some headaches a little later on. That's probably just good general practice regardless of whether you have ethanol in your fuel or not. Filters. Again, these old tractors, a lot of them had the sediment bulbs. People have come back and added inline filters, this is the example here. And I'll show you a picture, or I think the previous picture showed where there was a sediment bulb and a inline fuel filter in place. You want to pay attention to these filters, make sure your materials are compatible, look at the seals. Also, you want to pay attention to in particular, the inline filters where they have a paper media, as to make sure that that is compatible with ethanol. You want to change them regularly. Again, you've got an old vehicle, you've dumped some gasoline into it for the first time in a few years. It may have already had some rust in there. You may have had some varnish, maybe a little water. It's all going to wind up over here, hopefully, in your fuel filter or your sediment bowl. Again, the older tractors have the sediment bowls. You want to clean them regularly. If you notice, this sediment bowl has some material in it. I was at a dealership the other day that had a whole bunch of old tractors in it, and pretty much all the old tractors had some sort of material in the sediment bowl. So a little maintenance goes a long ways here. Fuel pumps. It's really not something for old tractors, but is related to older vehicles. You do want to pay attention to them also. Switch out them as needed to be ethanol compatible. Watch for plug ports. And here a use matters. If you use your vehicle a little bit more, then you probably will have less problems. Fuel tanks and lines. Coming back to the tanks, this is probably where I should have started this discussion, but you take an old vehicle, an old tractor that maybe has been sitting out in the shelter belt. It's hard to say what's gone on with that machine. In this case, there's the fuel tank is missing its cap. You bring this tractor in and start working on it to make it up into a running order. The first thing you need to do is go clean your tank. A lot of stuff has gone on over the years, and a lot of things have probably happened in that tank, and there's a whole bunch of gunk there that needs to be cleaned out before you even think about running it. In some cases, particularly pitted tanks, you may want to go and coat the inside of the tank. In worst case scenarios, if it's got holes, you really need to go replace it. Once you get your fuel system or your tank up to operating, what you want to do for storage is keep the tank full, and then for longer term storage, add a fuel stabilizer. I have had people tell me use a fuel stabilizer regardless of how long you think you're going to store the tractor. It just will make your life a little easier. Pay attention to the cap and the vent on the tank. Make sure they're in good working order. If the seals are deteriorated, then you need to replace them, because you may have cleaned up the tank, coated it, but if your cap and vent are deteriorated, you're going to keep adding water into the tank, and that's not good. Your lines, your fuel lines, you want to clean them, inspect them, and then if there need be, replace them. Again, replace them with ethanol-tolerant materials. Some other considerations with old engines and ethanol is the ethanol tends to vaporize more readily than gas. And so what can happen is that once the engine gets hot and you shut it off and you leave a little fuel in the carburetor or in the intake manifold, it'll vaporize and pressurize that area of the fuel system. The end result is the fuel system will not allow, that pressure will not allow fuel to flow through the fuel system, and so if you decide to turn the tractor over and start it, no fuel will flow. And basically once you have vapor lock, about all you can do is let the system cool down till the pressure is relieved, and then you can start it. The other thing to talk about is cold start. Ethanol at lower temperatures does not volatilize very well, and that can make it a little more difficult to start a tractor or vehicle. Now, this is more of a problem if, per se, you were to buy some summer blend gas and then wait until January to use it to start your vehicle. The fuel dealers will create summer and winter blends, and so if you bought January fuel in January and start your tractor with it in January, the ethanol content is likely been reduced, so just for that purpose, to make sure that there isn't a cold starting problem. So it's probably, cold start is probably more of a problem if you haven't had used your full summer blend up by the time you get to cold weather. Something to be aware as you're using these fuels in these older vehicles. Okay, now you can take this that, all right, there's a lot of problems with ethanol, and that's not what I want you to leave this webinar with. There is a lot of ethanol advantages to having it in your system. First thing is the system cleaning. You need to take that old system and make sure it's clean before you start. But once you get it clean at the start, with ethanol in your fuel system, it's going to stay clean. Also, if you have some of these older tractors that have been in use all along, where you know, since the 71 or 60 or 55, this tractor's been used some amount every month, it probably doesn't have a dirty fuel system. Why? It's because ethanol has been in the system and it's been keeping it clean, taking out a little bit of varnish here, a little bit of varnish there. It's also been controlling water. I'm going to jump down here to talk about water control. Ethanol, because it is hygroscopic in nature, will pick up water. Now, the bad side is if you take your fuel tank and leave it half full and open it up to the atmosphere, you're going to have water condensing in the fuel system. And if you leave it set for a long time, then you're going to get a large amount of water condensing in the fuel tank. And that, of course, isn't good. On the flip side of it is, because ethanol is hygroscopic, if you have your tank half full and you get just a little bit of condensation overnight or even over a week, the ethanol is going to grab that water, absorb it, and it's going to go through your system. The ethanol will carry it through the fuel system into the cylinder. It'll be combusted along or vaporized along with the fuel consumption and shot out the exhaust pipe. So if you have had a little bit of water problem, the ethanol is going to help you. If you have a big water problem, of course, it's not going to help you. But then you've had a big problem because you had a lot of water there. Going back to your half full fuel tank, if you had it half full of pure gas, you still have the opportunity for condensation in there. The disadvantage now with the full pure gas is it's not going to take any of that water out. So that water is going to stay in the tank till it gets to a large enough volume that it just flows into the fuel system or into your line and onto your carburetor, and then you're going to have some real problem. The other thing about ethanol is it does give you a nice octane boost, and again, we know octane is there to prevent knock in engines, and we know that knock is not a good thing for any engine, and older engines are less tolerant of knocking than newer engines. The other thing is cooling. Ethanol burns at a lower temperature than regular gasoline. If you have the air-fuel ratio set properly, so that you're in that a little bit richer mix that I've already talked about, the temperature inside as the fuel's burning is going to be less than if you have with pure gas. What that means is your engine is going to run cooler, and that is a good thing. Again, engine heating is not very good on the life of your engine. You also get a little advantage in your charge air. Again, I talked about how the lower the volatility of ethanol, it'll cool the charge air a little bit more, and you'll get a little better charge into your engine, and so you get a little better efficiency out of your fuel, as well as helping with the engine temperature. So, what do I want you to take home today from this conversation? Well, first of all, if you've got a 40-year-old tractor or a 40-year-old car, it has needs, regardless of what fuel you've ever put into it. The fuel lines may need to be replacing. After 40 years, things happen to rubber, things happen to metal. You need to go through the system and make sure that the system is not dirty and corroded, particularly if it hasn't been used a lot. You have a car that's set out there in the shed for 20 years out of the last 40 and that hasn't been run. It's probably got a lot of problems. A lot of the seals may already be deteriorated. There's probably water in the tank. There may be rust in the tank. You need to do some stuff to get that vehicle up and running order. When you're doing that, then you need to pay attention and replace these parts with ethanol-tolerant parts. Once you get the machine up and running, you need to make sure the engine mix is a little bit richer with ethanol fuels. And then when you're storing the machine away, make sure you fill the tank to leave it be, and then add some fuel stabilizer, and then shut the fuel off from the carburetor so that it stays in the tank and you don't get a lot of water collecting in your lines and into the carburetor. So with that, looking a little bit to the future now, we're going to see ethanol continue to be in gasoline. We will see more blends with greater energy greater ethanol content coming. What those numbers will be and when they'll be available, I don't know that answer. I just know that you will continue to see ethanol in fuels, and there's going to be more blends available. But gasoline will also continue to evolve. Engineers are out there working on engine advances, so the engines are going to change. The refiners want to improve their business, so they're improving what they do, and so there's advances happening there. Air quality, we all love to breathe. We like clean air. The air quality demands will continue to change our fuels, and so you're going to see a lot of changes coming in the future. And I use this example. I've got a Model A here, 2005 F-150. The fuel that was available when this Model A was first built is certainly different than the fuel that is available when this 2005 was first built. And what we may see in 40, 50 years or even 10 years remains, it's hard to say what it's going to be, but I will bet that it's going to be much different than what's available today. So with that, you need to think that our fuels are going to be evolving as we go forward, and understand that that will mean we need to take and change how we look at our vehicles. If you're really interested in this topic, for some more information, I have we'll be presenting a webinar next spring on this topic with regard to small non-road engines and ethanol. There's a publication out there already on the topic, and then this presentation will be distilled down some into a publication that should be available also next spring. We have two good resources that I use a lot in preparing this presentation. Is the Changes in Gasoline 4 guide that's shown there in the right-hand corner, and then also the effects of intermediate ethanol blends on legacy vehicles and small non-road engines, publication by Oak Ridge National Labs. Both are really good resources, and I highly recommend, if you're really interested in this topic, get those publications and take a look at them.
This webinar has been brought to you by the Farm Energy Community of Practice and the University of Nebraska Lincoln Extension. For more information, go to farmenergymedia.extension.org.